Hi, so this question needs a little bit of clarification before we can really answer it. For the question, can a square have an area of 4x squared minus 4x minus 1? Well, there are a lot of numbers that take this form. For example, if we let x equal 2, then this is equal to, just take me at my word, this is equal to 7 when you plug 2 in. Well, whatever, it's 16 minus 8 minus 1, right? That's 8 minus 1 is 7. And so, yes, a square can have an area of 7 if each of its sides is square root of 7 units long. So, yes, it can. But I have a sneaking suspicion the question actually is asking if a square can have an area of 4x squared minus 4x minus 1 while its side lengths are whole numbers or integers. And that's a little bit trickier. So let's suppose it's true. What would happen if that were the case? So we have 4x squared minus 4x minus 1, and we have it being set to n squared, right? Where what I mean by this is if a square can have this area, then it must have, if it can have this area while having whole number side lengths, then its area must also be the square of whatever its side length is. So we're going to call it side length n. Now, what do we know about this n? Well, it can't be even. And why do I say that? Well, if n is even, then n squared is even. And if n squared is even, then n squared can't equal 4x squared minus 4x minus 1 because 4x squared minus 4x is going to be even because it's 2 times some number, 2x squared minus 2x. And then if you subtract 1 from that, well, 4x squared minus 4x minus 1 is an even number minus 1, which is odd, which means that n can't be even because n squared must be odd. So n squared is odd means that, and this is true if and only if n is odd as well. So we know now that if a square has this area, its side length must be an odd number. So let's see what happens if we just kind of play with that idea a little bit. So we have, oopsies, that didn't need to be there. So if we have 4x squared minus 4x minus 1 equals n squared, where n is odd, well, if n is odd, then it can be written as an even number minus 1, right? Every odd number is an even number minus 1, and an even number is just 2 times some other number. So we're going to rewrite this as 4x squared minus 4x minus 1 is equal to 2k minus 1 squared. And this factored out is 4k squared minus 4k plus 1. So these look pretty similar. We're just going to kind of work them down a little bit, though. So I'm going to pull a 4 out of the front two factors, 4x squared, 4 times the quantity x squared minus x. I'm going to move the 1 over to the other side and pull a 2 out of everything. I'm going kind of fast here. I'm running out of time. This is equal to 2 times 2k squared minus 2k plus 1. All right, so this equality is the same. These are the same, right? And so now if we take a 2 out of each of these, we'll see that 2 times x squared minus x is equal to just the inside of the quantity there, 2k squared minus 2k plus 1. And notice what just happened here. So here on this side, we have an even number again, because it's 2 times the number. But on this side, we have, again, an even number plus 1, so an odd number. And this cannot happen. So no, because no matter how we look for a whole number side length to this question, to this this equation, these terms, it cannot be the case. N can't be even and n can't be odd, so it can't exist. So no, a square cannot have an area of 4x squared minus 4x minus 1 if the side lengths are whole numbers.